Good afternoon, everyone, and welcome to today's online training, How Machine Learning is Changing Data Analytics in Government. My name is Emily Jarvis, and here at GovLoop, I'm our Senior Online and Events Editor. And today, I will also be your moderator, so thanks so much for joining us. And a special thank you to our partners at Databricks and Amazon Web Services for helping us put on this training. So let's dive into the good stuff. Agencies need good, clean data in order to make informed decisions. However, manually culling data into pipelines, well, it's time-consuming and it's error-prone. Take, for example, how federal agencies aggregate healthcare data from states. If that information is improperly reported and stored for federal healthcare agencies, it's useless, right? You can't do anything with it. The good news is that today we've got two experts who will share how, with the right system integrators, agencies can transform their data analytics platforms in the cloud. But before we get going, I do have a few housekeeping items to cover. If you're on Twitter, please share what you learn using the hashtag GLTrain. The person who tweets the most using that hashtag will get a GovLoop t-shirt, and trust me, you definitely want one. We also have some great compliance resources available for you to download, including this slide deck. They're right there on the right-hand side of your console, so make sure you are checking those out. We hope you don't have any technical difficulties, but if you do, send us a message to the Ask a Question box, and my colleague Maddie will make sure to get all of your questions answered. It's in that same portal where you can ask our experts questions. And please take a moment to fill out the feedback survey on your console. We really appreciate your feedback, as we're always looking for small ways to improve our online trainings. Finally, we are recording this training, and we'll email you a link to the on-demand version tomorrow, so you can listen to it again, send it to a colleague, all of that great stuff. So now, with all the housekeeping items out of the way, let me introduce you to our wonderful presenters. First up, we have Brian Durking, who's the Senior Director Partner for Marketing at Databricks. Brian has been in the technology industry for more than 20 years in roles including project management, product marketing, business development, and partner marketing. He regularly speaks at conferences and public events and writes blog posts and white papers on analytics. Joining Brian, we have Donghwa Kim, who is the Director of Application Engineering at NewWave. There, he is currently acting as the lead technical architect for one of the Center of Medicaid and CHIP Services programs. One of his responsibilities at NewWave is including overseeing the company's data sciences practices. NewWave is one of the premier technology partners for CMS. They are both obviously well equipped to talk about machine learning and changing data. So with that, I'm going to turn things over to Brian. So Brian, the floor is yours.
Thank you so much, Emily. Hi, everybody. Thanks for joining us today. I'm very excited to present this to you, and very excited to be presenting with Donghwa, whom I've seen speak a number of times, and he has a wealth of knowledge. So this is going to be a great session. So a little bit more about how machine learning is changing data analytics in government. We'll talk a little bit today about how analytics in government is focused on better, safer, and more efficient as kind of the three outcomes. Donghwa will cover this customer implementation, and then we'll go into next steps in a Q&A session. So let's jump right into it. I think one of the things, to try and get everybody up to speed is let's talk a little bit about some of the key underlying concepts and terms and the evolution of analytics. Initially with analytics, we had, the business intelligence capabilities with data warehouses, and this gave us reactive analytics. This gave us reporting and information about what just happened. And the next step that we saw in the evolution was to be able to move into big data analytics, where we started to incorporate predictive analytics, and that was more proactive. So we could predict what was going to happen in terms of different kinds of use cases, like trying to understand of a particular set of constituents, how likely are they to change an opinion or to move to a different service or something like that. And then, what we've really seen here in the last 5 years blossoming is autonomous decisions. By unifying data and AI together, and we start to get the advanced machine learning capabilities, we can now train systems to make decisions for us. Which sounds a little frightening, but as you'll see in the examples that we're using, this is much more, kind of low level and really just helps us to scale quite a bit. And as part of this process, what we saw was the dawning of Spark as a unifying technology. Spark has now been donated to the Apache Foundation as an open source project, but it really allows us to process data at scale and to be able to bring data and AI together. So we'll talk some more about that in a few minutes. But as we talk about analytics, there's a lot of different terminologies that we're using here, and so let's put a little bit of a definition around these, and each of these kind of progressively builds on each other. And we're interested in feedback, and your thoughts on this, so do feel free to throw questions into the question window here. But with advanced analytics, we have the ability to do data mining as well as machine learning, forecasting and pattern matching. And this really, kind of starts from what we saw with that data warehouse capability, where I'm just receiving information to now being able to be more interactive and to be able to posit questions. The next level that we see is artificial intelligence, where we start to enable computers to mimic human behavior so they can actually understand and make decisions. But with machine learning, we start to get even smarter here. Now the computer can learn from different things that are going on. So for instance, if we're working with like an Amazon recommendation engine, we can make a recommendation to someone, but then we can take the feedback on whether or not they actually took that recommendation to continue to evaluate the model and to improve the model. So that way we have a feedback loop, and we allow our machine learning tools to explicitly learn from what's going on and how people are reacting. And then finally, we have deep learning, and this is an area that we start to build out neural networks, and we really start to be able to take data, learn from it, and then make that part of the whole process. And we'll show an example of that, which is a fascinating area. So looking at the state of analytics in the federal government, we have definitely an increased focus on analytics and AI, and one of the main outcomes, and we'll talk about some of the others, but one of the main goals here for this particular initiative, which is the Big Data Research and Development Initiative, is operational efficiency. So the government has made a $200 million investment here, and what we see is the outcome here is the ability to automate, millions of hours of federal worker time by being able to automate that through some of the different machine learning capabilities that we're talking about. So that $200 million investment becomes a $9.6 billion savings down the line. So that's one example of how we see being able to bring analytics in and the potential investment and then the potential return that we can see on this. And so we'll show a couple of different examples. But, one of the things about this is, as we move from the investment to the savings, is we want to do this data-driven automation, and we find that it can be very difficult to bring together the data itself. So we see 97% of federal IT managers struggle with the data itself and how to bring the data in. 73% say that challenges extend beyond just harnessing and securing the data to actually analyzing and interpreting it. And this is based upon a pure storage study. And what we see at Databricks, and this is something that we use frequently to try and explain this, is, if you're trying to do AI or machine learning, writing the machine learning code is just a very small part of the whole process. As you can see, the green box in the middle there represents the machine learning writing. But, there's the whole configuration of the systems. There's the data collection itself. There's feature extraction, data verification, all these different processes that go on. Once you've made these analyses or made the data available, what's your serving infrastructure? How do you monitor all this? So that's a whole bunch of the different technical debt. There's always, of course, different kinds of internal, systems and things that need to go on in terms of executive support, and how do you get people bought in, and how do you change the culture of an organization. So there are a lot of different elements that go into making AI successful, but so many of these are technical capabilities around trying to get the data just so, because machine learning, applications are very particular. They're looking for data that is very clean and organized. And so what you find is there's a lot of work that needs to be done to get that data to the state where you can actually get valid and valuable predictions out of it. So let's talk a little bit about some of these use cases. We talked a little bit more about the efficiency piece, but we see three main outcomes that most government projects are looking at. One of these three, or in some cases multiple. how to get better, how to provide better services based on deep objective analysis, how to provide more safety, to protect against threats with real-time insights, and how to get more efficient, how to analyze costs and find patterns that enable cost reduction. And all of this needs to be done with the built-in security and privacy protection that we come to expect in terms of what we're being able to do, and making sure that we're ensuring that we have privacy built in, and that we're not sharing personal information and things like that, and the security so that these systems are hardened and able to be protected. So let's look at some examples of each of these. An example here is an example of Better, where we're analyzing population health data. So one of the things that's been done in this particular case, and this is a live case for a customer, is we've performed ETL, which is extract, transform, and load, which is basically the data cleanup that we talked about a little bit on the slide with the green box. How do we clean that data up to make it able to be analyzed? Maybe we join it with other data sets to provide more context. And in this case, on population scale, Medicare and public health data to identify trends around the country. So the outcome of this is we can identify hotspots and generate insights both on things like fraud. Again, we can be looking at efficiency from that perspective, but also looking for better services in terms of disease outbreaks and providing guidance for diagnosis and treatments. So this can be anything from, kind of going back to the BI reporting kind of level of, I just need to see what's going on right now, show me where these disease outbreaks are, to being able to incorporate machine learning capabilities and start to predict where am I going to see outbreaks. And that might be based upon historical data, and that data might also be combined then with, with other types of data sets that we have. So that ETL process and then the machine learning put together allow us to actually start to predict, where we might see outbreaks. So that provides better, support and better services for our constituents. Safer is another example. So here we're trying to identify suspicious behavior. So we're leveraging a neural network, as you can see here in the image of the architecture, and that provides deep learning to be able to identify suspicious behavior and security footage in this case. So we're automating the analysis of this video stream here. Obviously, we can't have one person monitoring 24/7 every video camera that we have. And so this is where the deep neural network and the deep learning allows us to be able to automate this. And so what the neural network will do is it will look at behavior that's going on in this courtyard, and it will start to track, and it will start to note what's normal behavior, and then identify specific issues on flagging when behavior is not normal. And as we look at machine learning and the ability to do this, we're working with massive data sets. And there's a good reason for this. We have one customer who originally was looking at more intrusion detection on a network, and they were able to work with 2 days worth of data, which didn't give them enough foresight or insight into what was normal behavior. If you thought about this courtyard video here, if I got 2 days worth of data, then probably what we would have is Saturday and Sunday data where this might not be a heavily tracked. And then on Monday, all of a sudden, we'd be looking back and we'd say, oh, these are a lot of anomalous behaviors because suddenly we have a lot of foot traffic. So that could definitely skew and make, basically the findings useless. So the customer was able to expand to 2 years worth of data just due to the scalability of Databricks. And that's where you really start to be able to get insights and start to think about, how is this impacting what's going on, and how can I really look at this in a way that's important. And that's, really key, because the other thing that we might think about is things like not just, historical data, but bringing in other types of data sets as well. So for an example, an example of efficiency here, let's analyze border crossings, and let's take a rich set of data, that tells me about border crossings, and maybe map it against a calendar. And then I want to use some predictive analytics to be able to decide what's the right level of resourcing for any particular day, as I'm scheduling folks out. And so one thing it might do is look at, July 4th and say, well, do we have, more than average border crossings, fewer than average, border crossings? Maybe we have more border crossings between the U.S. and Canada. Maybe people are going back and forth for Canada Day events and then 4th of July events, for example. So those types of things would be interesting. But having that data alone in terms of historical data isn't nearly enough. Now we want to start to layer other types of things that we see as being predictor variables. Let's take weather data, for instance. What was the weather on each of these days when we had different kinds of traffic? How does the weather impact it? Is it positively or negatively in terms of crossings? And then we can start to take weather prediction information and bring that into our predictive element to start to determine, well, the 4th of July is going to be overcast, and we know that on overcast days we have fewer crossings. Therefore, that, both historical data on crossings as well as any kind of, weather data can be incorporated to help us get a truly, refined prediction and therefore staff appropriately. So we might have 4 or 5 different predictor variables like that. That are all elements that we bring into our analysis. And that's where you really start to get these truly massive data sets. But those truly massive data sets, are enabling you to make very highly refined predictions. So we have customers who are working on a corpus of 10 terabytes or 10 petabytes of data in terms of the data sets that they have. That's they're a couple of years worth of data, and then are introducing 150 terabytes worth of data on a daily basis, and this can be both batch data and streaming data, so the data can be getting updated very, very quickly and then being incorporated right into that analysis. So super important to be able to scale up and be able to handle those massive sizes. So I'll just quickly go through a little bit about who Databricks is, and then I'll turn it over to Dongwa, but just a couple of different examples of the types of work that folks are doing using Databricks. We have the Citizenship and Immigration Services group here, who's federating data from many sources to improve decisions. And right back to that point I just made about many different data sources that are being used to give you really true insights into what's going on. More than 20 different data sources are being used here to process visa requests, for instance. So the data is being federated from different sources. Being able to put through that, be put through that ETL process to be joined and to be able to be, cleaned and everything, and then available for machine learning uses. Another example here, U.S. Air Force, generalizing data analytics solutions for all its mission centers, predictive maintenance on the age of, aircraft and other, items at a base. And if you think about the different kinds of machine learning algorithms that you can use, you start to get into some really interesting examples. So, for instance, for maintenance, at the base, we might even be looking at maintenance of the trucks that are being used to haul materials around at the base. And I saw one customer who actually took what's known as a market basket analysis. This is a known machine learning algorithm, and you typically use this for being able to tie different relationships between items. So the most common thing is, you go to the grocery store and you buy some meat. If you buy ground beef, it might predict, oh, you're probably going to want hamburger buns too to go with that, just as a, or you might want ketchup, different kinds of things that are associated together. Well, this customer actually took repair of different machines and then started to tie together other systems that might fail around that time. So for this truck, you might say, oh, we're being asked to repair a belt on the truck. This belt should typically last 12 months. It's only lasted 6. And that might flag, hey, we should also look at a couple of other things. For instance, the water pump might need lubrication, or the bearings might be shot and might need to be redone. And maybe that's the wear that's causing the belt to wear out sooner. It's not necessarily something that, the machine is thinking about this system, but the machine is looking at that correlation, and having seen that in the past, can then, say it, there are these correlations. So that's where a market basket analysis might actually be used in a maintenance kind of an example. So those are just a couple of examples of the types of things that folks can be doing with machine learning and bring that all together. At Databricks, our vision is to accelerate innovation by unifying data science, engineering, and business on our unified analytics platform. We are the original creators of Spark, Delta Lake, and MLflow. We have over 2,000 global companies using our platform across big data and machine learning life cycles. And when you look at Spark, really this was the key piece that started this all off. Was typically folks had machine learning systems, but they didn't have a way to bring the data together with the machine learning, and that was a problem. And Spark really bridged that gap and started to introduce the huge kinds of leaps we've been able to make in machine learning and analytics. So that's a huge part of that. That is an open source piece. So Databricks was founded by the original creators of Spark, but now they have donated it to the Apache Spark organization, and we continue to contribute and help foster Spark. So that's one example of some of the innovations at Databricks. Another newer one that we've introduced is a thing called Delta Lake, and this is for organizations who needed to have the ability to store massive amounts of data in a data lake, but then also they needed to have the data be reliable and high enough quality to be able to be accessed by machine learning capabilities. And so we introduced Delta Lake to be able to refine the data that's inside of a data lake and make it much more useful for machine learning. And Donghua will speak a little bit more about this, but that's another piece that we've developed and then we've turned over to the open source community. And last is MLflow, and this was something that as we worked with customers, we saw that people were having difficulty managing the life cycle of machine learning because people will do, many experiments. If you did 60 experiments on different a machine learning algorithm, you might, decide that, oh, the results for number 18 were the best, but, which library did I use? Which version of the library? Which data set did I use, et cetera? And so as we talked to a lot of data scientists, they admitted they were tracking this in spreadsheets. And so MLflow becomes an automated way to be able to track all of those experiments, to take those projects and package them up then and be able to share them for reproduction on any platform, so you all the way down to your laptop. And then to be able to take those models and be able to deploy that. So if you give that to your data engineering team and ask them to put that out and deploy it, it has all the information about, which exact version of Spark did you use, for instance, and which data set, did you use, et cetera. So this is another piece that we've developed and then put into the open source community with MLflow. So those are just some of the different innovations at Databricks that we've given back to the community. Donghua will speak about these to some degree as he covers the CMS presentation. And so, Donghua, I'd like to turn it over to you.
Yeah, thanks, Brian. So I'll briefly go over NewWave, our customers, and then we'll get more into presenting solutions that we're providing for one of our largest customers, which is our CMS. So these are the list of our customers. CMS, we work for CMS, and then we do legal work for HHS. We have some work being done for NOAA, FEMA, and CDC. But about NewWave, so we are about so this slide is a little bit outdated. We're a mid-sized company. We have about 400 employees, and we're constantly recruiting. We have 11 prime contracts at CMS. We support all 7 CMS centers. And I'm really proud to say that we are CMMI level 4 for services and development. And I think there are only a couple of companies out there who have achieved this kind of status. Of course, we are Databricks, a gold level partner within federal space, and then we work closely with AWS. So we have been working with CMS for closely about 15 years. As you can see, CMS's yearly budget is about close to $800 billion. And as I mentioned earlier, we have about 11 prime contracts within CMS, which includes chronic condition warehouse. It's one of the largest healthcare data repository in the world. And we have recently won another large contract to deliver innovative development and operational services. CMS is very important customer to us, and it's a unique customer. CMS oversees many federal healthcare programs, including those that involve health information technology. In addition to Medicare, which is the federal health insurance program for the elderly, and Medicaid, it's the federal needs-based program that helps with the medical cost. CMS is the agent which enacted HIPAA. I hope you're familiar with what that is. So CMS is unique in a way that it's where the federal government converges with healthcare payments, healthcare policies, and healthcare IT. So some of the data challenges that NewWave is providing innovative solutions for CMS is that CMS collects a lot of data. CMS ingests, stores, analyzes, and then disseminates large amounts of data. Now, currently, CMS data is integrated from administrative, transactional, and medical records of beneficiaries. So just to put this in perspective, CMS hosts information about approximately 57 million beneficiaries in Medicare and about 72 million in Medicaid. So it supports over 100 million American citizens. So yearly they collect about 2 billion data points. So as you can imagine, privacy is one of their highest concerns because they store PHI and PII information. We will cover more about this later in the presentation. So, and another point about CMS data challenge is that we need to provide them with centralized view, meaning that we need to retrieve data which is spread across multiple systems for analysis, which can be time-consuming and expensive. CMS currently has over 30,000 individual tables, and some of these tables have billions of rows and hundreds of columns, so you can imagine the complexity of the data that they have. So our objective or our vision is to provide a simple and reliable technology and data experience for all of our stakeholders. So we want to create a platform that meets current and future data needs across the data lifecycle, which includes data collection, analysis, hypothesis, and reporting, and provide ability to integrate on-prem legacy data with new data sets. And we want to take all the disparate data that the center has and make them accessible by both technical and non-technical users. So that's one of our main goals. And we want to provide a robust data governance, meaning that we want to provide a platform that can reliably and securely present a 360 view with consistent data definition and metadata management. And we want to do this in the cloud and leverage the power of the cloud and cloud-native data analytics tools and services to scale for varying computing-intensive needs. So how do we do this? Leveraging our Databricks. So just to give a little presentation of what Databricks can do, we find Databricks to be really developer-friendly. It supports multiple languages, including Python, R, SQL, Scala, and Java. And it has a built-in machine learning libraries, along with algorithms and utilities. But if you're not satisfied with Apache Spark machine learning libraries for some reason, then you can also bring in other popular machine learning libraries that are out there, such as TensorFlow, Keras, and Scikit-learn, and etc. And then Databricks, they support a different type of runtimes for machine learning. It also supports CPU and GPU instances. So you don't really have to manage your infrastructure. You only have to worry about how do you carry out your data engineering and your data science experiments. So in terms of the flexibility, since it's in the cloud, and as I mentioned, you don't really have to maintain your own infrastructure. You just focus on writing code. It takes the power of the cloud to the max, meaning that it has the ability to automatically scale up and scale down. It has very useful notebook feature where you can do real-time collaboration and communication with your peers. And it also provides a command line interface and also REST API for any type of automation that you want to carry. For example, if you want to create a data ops pipeline, then it's really easy to do. Just tap into your existing, like Jenkins or any type of DevOps infrastructure and integrate that with a REST API that Databricks provides. So Delta Lake, Brian mentioned this, covered this earlier. So Delta Lake is really exciting product, and we are really grateful that Databricks decided to open source it and release it to the community. So Delta Lake simplifies, the data processing architecture significantly. It's able to do batch-oriented processing. At the same time, it supports real-time streaming. And on top of that, it has, ACID, transactional capability, meaning that multiple writers can simultaneously modify a data set, which will be presented as a constant view. Within Data Lake, there are multiple data pipelines. There can be multiple data pipelines that can read and write data consistently. And it supports DML, and it has really cool operation called upsert, which literally means update and insert. So, it is done using merge into syntax. Writers can modify your data set without interfering with jobs reading the data set. So, you can do, insert, or, you can, if the data set is already there, then you can do update to the data. It provides a schema enforcement, to ensure that you have correct data type columns and, prevent any type of data corruption. And really cool concept of a data lake is time travel. And this ties really well with MLflow, as Brian mentioned. As a data scientist, they do different type of different runs of machine learning or deep learning experiments. They want to make sure that if they want to replicate that result later on, they need to work with the same data set that they carried the experiment with. So with every write, Delta Lake creates a version, and with which version is associated is a version ID. So you can go back to time where you can go back to a version of data either using timestamp or with a data version ID. So tying that with MLflow is a really popular concept. So to cover MLflow, MLflow has three separate capabilities. It has a tracking capability for storing parameters, the metrics, and any type of artifacts that was used, and then the source code that you ran the experiment with. So it's really useful for you to keep track of different experiments that you're carrying out. And MLflow has a packaging capability. ML project is a specification that specifies how to organize a machine learning or deep learning project. And at the heart of that is ML project file. It's a YAML specification that you can check into your version control. And then, model management is where you productionize your machine learning. As a data scientist, it's not really easy to productionize the machine learning model that you have created. This is where MLflow can provide, great support. So it's packaging the final model in a platform agnostic way. And then, it integrates with a different number of platforms, including REST servers, Docker, and even AWS SageMaker. So MLflow is really exciting product that we're currently working with. And I want to get a little bit into, data as a service concept. So, we wanted to break away from heavy dependence on ETL. We wanted to leverage the power of data lake as much as possible. As you know, ETL can be really expensive and time-consuming to get up and running, and it's also expensive to maintain. Business requirements and data needs to constantly change. And if you are waiting for your downstream operations or IT people to come up with new ETL scripts, it can take weeks and months, which is not the ideal situation for data analysts. So and also ETL doesn't really take into consideration of the fact that someday data can be useless, but really you may be missing out on useful insight that's buried in the data set. And another downside about using ETL is you're always working with the stale data. You're not really working with up-to-date data. So we wanted to provide a data as a service environment where data analysts, data teams, and business users can work together and then really come up with that business insight that's necessary to drive new healthcare policies and come up with new business ideas. So there are certain things that we are looking for when we create a data as a service, and one of the concepts is a virtual data set. So virtual data set is just a transformation that's built on top of immutable physical data sets. It's just a stack of data transformations, and you can query virtual data set using SQL query. And then you can also chain multiple data sets together. And there are 4 things that I'm looking for when I work with virtual data set. First is, I like tech knowledge that sort of enables users to, add data set without really worrying about schema. So, AWS Athena, along with AWS Glue, provides that kind of an environment where you can just drop in a file. AWS Glue, inspects the file and then comes up with metadata information that's connected to AWS Athena. So that's the kind of scenario that I'm looking for, really usage of being able to work with multiple data sets. And the second aspect is high throughput and scalability. Since this virtual data set can be leveraged by machine learning, iterative machine learning, and deep learning, constant querying, you need a more performant data set that you can work with. And a third aspect is security. It must be able to provide fine granular access control, especially within healthcare space. That's really important, that you are only exposing the data to people who should have access to the data. And you really need to be able to get into that fine granular level of column level access, so that you are not really exposing a PHI or PII information to the people who should not have access. So being able to integrate with a security provider or security access management platforms are really important. And it must be able to support multiple data sources, such as data lake, relational database, NoSQL, and whole other slew of data sources that you may be running into. So this is sort of like the big picture of we are leveraging all these technologies together. As you can see, a data lake, a Delta Lake is at the center of being able to ingest real-time data that's coming in via Fire API, and also enabling us to ingest data via batch-oriented processing. And Delta Lake has a concept of bronze, silver, and gold data states. So you may have a bronze table that's just raw data ingestion that keeps data for a long time, and this concept is really important because as you do the data transformation and as the data as the data gets closer to production ready business level aggregation, you may find out that whatever transformation that you have added on top of the data set may not be meeting your business needs. Then you are able to go back to the raw data that's in the bronze table, and then be able to reconstruct adding on a business logic on top of it, and then come up with a new version of a data set. So Delta Lake really provides that capability of us to utilize that asset compliant, transactional, and also being able to use both real-time data ingestion and batch-oriented ingestion. And then like I mentioned about a data service, we are leveraging Looker for data modeling layer for data analysts and business analysts to be able to come up with a data model, providing that agility of data, which goes through Dremio, which utilizes Apache Arrow as the compressed in-memory columnar data store that can reach out to different data sources, including a data lake that's in S3, any type of relational database, or even to NoSQL databases. And from that, we can run a Databricks Spark to do any type of machine learning and deep learning experiments. And as you can imagine, we are leveraging MLflow for keeping track of all those experiments. So I just want to pass on the message that CMS is hosting AI challenge. The grand prize for this challenge is $1 million for the first winner, and then they have hefty award for second and other winners. So please check out that short URL that's shown at the bottom of the page. And of course, NewWave, we are hiring. So if you are looking for an environment where you want to explore Databricks and the cloud, different cloud services, please, give us a ring. I think that's it, Emily. That's all the content that I have. I want to turn it back to you.
Wonderful. Thank you so much. It is now time for some Q&A, so if you have not submitted your questions yet, feel free to do so right now. But I'm going to bring Brian back into the conversation. And Brian, I'm going to start with you with a question. So we talked about a ton of information already in this training, but I just want you to kind of come back to one part in particular. You were mentioning Spark, you were mentioning Databricks. I know there's a strong connection between the two of them. Share a little bit more about that relationship.
Sure, yeah. So Spark was originally created by a group of folks who actually are the founders of Databricks. And so Databricks is essentially built on top of the open source Spark product, which we donated to the Apache Foundation. So when you run Databricks, you are running Spark underneath, and then we've built on top of that and made different kinds of optimizations. We've made the engine run faster just based upon our own knowledge of tuning Spark. We've enabled you to have things like notebooks so folks can collaborate, both data scientists and data engineers can collaborate together in the notebooks. We've added these other analytics frameworks, as Donghua talked about. So if you want to run your ETL using Spark in Databricks, but then you decide you want to run your machine learning against maybe Spark, but maybe 2 or 3 other machine learning frameworks just to see the different results. You might run Keras and Horovod or something else like that, so that you can then compare the results in these different libraries. A lot of the libraries have the same underlying machine learning algorithms, but then they get slightly different results, and that way you can optimize your results. So those are a couple of examples. I think the number one thing, though, about Databricks for being able to run Spark is that to install and configure Spark is very time-consuming. There are a lot of things to know to be an expert. When you're running Databricks on AWS, you're able to simply go in and start Databricks and choose your cluster and your hardware and have it running instantly. And as Donghua mentioned, there are a lot of different things that typically go into kind of operational management of an analytics system. But a large part of that is automated here. So things like clusters being spun up and spun down based upon your usage. If you have a huge machine learning run, Databricks can look ahead and see that this is coming. It can spin up additional clusters to be able to handle the capacity and then immediately spin those back down so you're not paying for that capacity when you're not using it. So for a data engineer or a data scientist, that allows you to focus on your job instead of having to focus on those operational kinds of things. And that's a huge benefit for folks in terms of just their efficiency. There was a question also that kind of relates to this that I'll pick up. The question was, is Databricks ETL or is Databricks machine learning? And the answer is yes, it's both. And that's the uniqueness, and that's the thing that originally is the kernel of Spark, is the ability to bring both data, or the ETL process, the data engineering side of it, and machine learning, or the data science side of it, together. And that's what Databricks is built on top of with Spark, and then expanded upon, is that ability to bring them together. So when you see a data scientist and a data engineer working in the same notebook, and a data engineer is working in Scala and saying, make these changes to the data set to make it ready for analysis, move these columns, get rid of these nulls, whatever kinds of preparation work they're doing, joining these two data sets. And then in the very next line, you see somebody who's a data scientist writing in Python or in R and saying, now run a decision tree analysis, or, whatever algorithm they want to run. That's really powerful. And as Donghua mentioned, you have the ability to do this interactively. You could leave comments for each other. You could see live typing. And I think for a lot of customers that I've talked to, originally they were interested in Databricks because of the scalability. The ability to run Spark 10 to 100 times faster is great. But then once they start seeing the data scientists and the data engineers working together, and they see how much that accelerates innovation, as opposed to, I need a new data set, I'll put in a JIRA ticket, or I'll send an email and I'll wait 2 weeks. But rather being able to say immediately, hey, I need a new data set, and within an hour or two, somebody else has said, okay, it's in the notebook now. That's where folks really start to accelerate innovation, and it makes a big difference.
Thank you for that background information, and it's always nice to kind of have a better understanding of how breaking down some of these silos is really able to speed up the process, build some efficiency in there. Donghua, I got a question in here for you. You and Brian just mentioned some of these. There's lots of different programming languages that you're working with. How do all these different programming languages work together, and how do you kind of streamline that process?
Yeah, so I think Brian did a fantastic job of introducing what Apache Spark is, right? So a good thing about Apache Spark is that no matter what type of language you're working on, you are always working with same concept. For example, Apache Spark has a concept for data frame, which you should be familiar if you're coming from a Python background, because you have pandas where you are constantly working with data frames, right? Apache Spark takes that same concept, and then no matter which language that you're working on, whether it be Java, Scala, or Python, you're always working with something like data frames. So if your team composition is made of Python data scientists, or some of them may be Scala, it doesn't really cause any type of friction, because the concept is always the same, and codes are really similar with one another.
Definitely. And I got a question in here that asked for sort of a bigger picture. We drilled down into some really great examples and some really great specifics. But Donghua, could you share, you were talking a lot about what you guys are doing with CMS and some of the machine learning and things that you're working on there. How has CMS been able to make themselves more efficient, or give me some end results here, how this is making this process better for the agency?
Sure. Yeah, CMS, as I mentioned earlier, is providing, healthcare for close to over 100 million American citizens, right? So they want healthcare delivery to be more efficient. Right. Traditionally, the way the providers or doctors were paid were based on, the concept called fee-for-service, meaning that as you get more sick, then doctors get more incentivized, right? They get paid for the number of, exams, number of tests, and then, how much, medicine they prescribe is how they bring in their income. But CMS is working for alternative payment models, or new model where doctors are incentivized more if their patients get better. So as you can see, we have a lot of need for data analytics, and also utilizing machine learning, deep learning to come up with a model that can work for both beneficiaries of healthcare and also for the providers.
Sure. No, and I think that really helps just kind of resonate, because sometimes you can get a little bit lost in all of the data analytics pieces, which are incredibly powerful. But at the end of the day, you guys are helping doctors and medical providers, make the country a little bit healthier. And I think it's always nice to bring that back to the mission. Brian, we talked a lot about some of the Delta Lakes and all of that fun stuff. How do these integrate with Spark's API? How does all this work together?
Great question. Well, Delta Lake is actually built on top of Spark, so it totally takes advantage of the Spark API. So folks who are using Spark can easily use Delta Lake. And one of the things that you see an example of if you look at some of the different videos is there's a very simple syntax variation that goes on. Instead of writing to Parquet K, now you write to Delta Lake, and essentially your code works exactly the same. So very, very easy transition for folks who are doing that already.
And then in addition to that, we've also got, these ACID or ACID transactions. What is that in relationship to the Delta Lake?
Yeah, that's a great question. So one of the original problems that you see with data lakes is that, folks are throwing all sorts of data in there. And if there's a failure on the writing process of the data, you get an incomplete data set there. So you may have a lot of different kind of remnants or fragments that are sitting around. And so that becomes problematic as you're trying to identify data sets. And then the other thing that happens is quite often you're trying to read a data set, and that data set might be getting updated at the same time. So with ACID transactions, it allows us to write the data. If there's a problem in the data write, instead of just dropping the process, we revert back and we drop all that data. So that allows you to really control that whole process and really make sure you have clean data sets. And then the other thing that Donghua mentioned was the time travel feature, which allows us to see differentiations or differences between different data sets. And so we can actually go back at some point and say, what was the data set at this particular point in time? And you think about, for auditing purposes, I need to understand why we made this recommendation. Take me back to the exact data set that this recommendation was based upon. Is super powerful from that capability. When you combine that with the MLflow lifecycle and the fact that MLflow also tracks then all of your different machine learning algorithms and runs, between those two, you have the ability to basically track back and see the lineage of your data throughout the entire process of machine learning there.
My husband is on the audit side of an accountant, and I can just imagine he would have little heart eye emojis hearing what you were saying about this, because, going back in and seeing a data set at any given time, I think is really powerful. And Brian, I want to stick with this topic for a second here. We got a couple questions in about the predictive intelligence part of this Spark and Databricks example. You mentioned a little bit with the border security example, if it's cloudy, if it's a holiday, things might change. How do these, really work together, and how can you make sure that the predictive intelligence is as predictive as possible?
Interesting. Well, nothing can really replace a good data scientist. Inevitably, it takes someone to put all this into place, and then also to then test and make sure that their results are accurate and they're providing good recommendations. You just always have to have that. Trying to put something like this into production without having that kind of testing and oversight is problematic. So. You really do have to do that, and what we see with our customers is, testing and then taking that data out. I know that Donghua has done this numerous times. You take it out, you try it on some sets, you get some feedback, you go back and you iterate. It is an iterative process. Donghua, I don't know if you could shed a little bit more light on that, perhaps.
Yeah, sorry, I was trying to deploy.
It happens to all of us.
Yeah, so leveraging MLflow, it allows us to keep track of different parameters that are going to experiment. And also, one cool thing about integrating Delta Lake and also MLflow is that, like you mentioned, we can always go back to the experience that we carried out at a certain point. Right, so if your results are coming out differently, then you want to see why certain visits are coming back differently, then you can always utilize data lakes time travel along with MLflow to go back into the time.
Wonderful. So we only have a couple minutes left here, and I always like to end these online trainings with one thing you're really looking forward to and then one takeaway for our attendees. Because I know when you come to an online training like this, you get a ton of great information and you're like, oh, what do I take back with me? So Brian, I'm going to start with you. What is the one thing you want these attendees to walk away with, and what is one thing that you and Databricks are excited for the rest of 2019 or into next year?
Yeah, no, that's a great question. I hope that everybody understands the incredible impact of bringing data and AI together, because I think that that's something we've tried to impress here is this is something that you haven't seen in other systems, and this is why we're having so much success with customers being able to put this into practice and have meaningful insights. There are a couple of assets that we've answered in some of the questions and we had on the slide here in terms of the ebook, the AWS training course that we offer. So there are some great places for folks to go, to get further information. As far as things that I'm looking forward to, we are continuing to work with AWS, and we're doing a number of different Dev Day events. So that's something to look forward to. And especially as we get into September, we'll have a number of those, and then of course reInvent. Purely from a kind of a activities type of side. When I think about more in terms of where the industry is going and things like that, I just see this further tighter integration of these different machine learning capabilities and integration between the different products. A number of folks asked about how does Databricks integrate with Tableau, for instance, or Power BI, or Looker, or somebody else asked about Informatica. And that's what's been great is that, especially with Delta, we're starting to see more and more of this ecosystem involved where people are working together and bringing these technologies together. So that, as Donghua has done with CMS, you can look at these different technologies. You can choose what are the best tools for my particular use case and for what it is that I'm trying to achieve, and bring those together. It just gives you so many more kind of tools in your belt that you can then put together and, make some really outstanding and important and impactful insights, like what NewWave is doing at CMS.
Wonderful. All right, Donghua, you've got the harder job here. You got to go second. What is one thing our attendees should take away, and what are you looking forward to in the future?
Yeah, I mean, I think, AI is not really about the future anymore, right? It's right here, and everything nowadays, involves AI, machine learning, and deep learning. So, I'll just encourage, all the audiences to just, dive in, take a drive. It's not, I think there may be some fear out there about learning new technologies and adopting AI into the practice, but there are a lot of resources, and Databricks makes it really easy for you to, adopt AI capability. So, I just encourage everybody to take a test drive. And you asked about exciting features. What I'm excited about is Apache Spark 3.0 release that's coming soon, hopefully. And then Databricks just announced Koalas, which is API compatibility with Pandas. So you are able to run Pandas code utilizing Databricks massive parallel computing power. So those are two features that I'm really looking forward to.
Definitely. Unfortunately, though, that is all the time we have today. Thank you, Donghua and Brian, for being our wonderful speakers. I do have a few quick reminders before we sign off. We will email you a link to the on-demand version of this training, so make sure you're checking your inboxes tomorrow. Also, be sure to download the additional resources in today's slide deck on the right-hand side of your console. There you can find the feedback survey. Go ahead and take that. Let us know how you thought this training went. Our goal with these trainings is to help you do your job better, and we really appreciate and value the work that you do every day. So thanks for taking the time out of your busy schedules to join us this afternoon. And a special thank you to our partners at Databricks and AWS for helping us put it on. Enjoy the rest of your afternoon, and we'll see you at the next training.